About geometric sequences, a sequence is geometric when if you list the numbers of your sequence, you can always obtain the next numbers by multiplying by a constant number. It can be 2, it can be anything else, it can be 3, whatever. It can be, it doesn't have to be a whole number. It can be pi, it can be 1/3. So here the next, if I multiply by 2, will be 8, and the next will be 16 and 32 and so on. This is called a geometric sequence. The number by which you are multiplying here is called a common ratio. I'll denote it Q, but you can use any letter. It's called Q because every time you want to get the next number, you have to take the previous one and multiply it by Q, sorry, here it's 2. And it means that the ratio between 2 consecutive numbers is always the same, and it is Q. This is why it's called a common ratio. Therefore, your recursive formula for this type of sequence is going to be, if you want to get the next number, you need to take the previous one and multiply it by Q. But if you want to list all the numbers, of course, you need to know the value of the first number. Okay, it doesn't have to start at U0, it can start at U1, U2, or wherever you want. This is your recursive formula. Your explicit formula is going to be, if I want UN, the explicit formula is used if you want to compute U18 without computing all the previous terms. So if you want UN, it means you started from U0 and you multiplied it by Q n times. So it means you have to multiply it by Q to the power n. Okay, and if it doesn't start from 0, you have to be careful with that number and think about how many times you did multiply your first term by Q to obtain this one. The sum of the terms, so I already said it for the arithmetic sequences, but the sum of terms in the sum of the terms of a sequence is called a series. So this is an arithmetic series. Sn is like U0 plus U1 plus U2. Once again, you can start from something else than 0 plus UN, which we'll denote with sigma notation, which means sum from 0 to n of the terms. But if you want to compute that, it's going to be the first term, which is not always U0, times 1 minus your common ratio to the power of, be careful, here is the number of terms in your sum. So you have to count them, because this is where you will make mistakes, divided by 1 minus your common ratio. The limit of your sequence. So here the limit is, if your common ratio, if its absolute value is less than 1, it means if your common ratio is between -1 and 1, then your sequence will converge towards 0. If your common ratio is greater than 1, then the limit of your sequence, it means you are multiplying by a number greater than 1. It means you are getting greater and greater numbers, and this time it will diverge towards infinity. There is something special here. If Q is equal to 0, then you get a constant sequence. Sorry, if Q is equal to 1, if Q is equal to 1, then you are multiplying by 1 all the time. So it means that your sequence is constant and it's always equal to U0, your first term. Then if Q is equal to 0, it's constant and equal to 0. So yes, this is true. And then if Q is equal to -1, something interesting happens. It means that you have, look at that, for Q equals -1. For example, if your first term is 4, then you multiply by -1, you get -4, and then by -1 you get 4, and then -4, then 4, then -4. So you get this sequence diverges, right? And then if Q is less than -1, your sequence has no limit, because it means that for -1, it's like that. It alternates between two values. These are the terms of your sequence. But if it's negative and the value is greater than 1, then it will explode like that. But still you will have no limit. If you want to test if a sequence is or isn't geometric, you have to compute the ratio of the next term over the previous one. Either you get a constant result, which doesn't depend on n, then the sequence is geometric, and the result you got is Q. If it's not constant, your result, if it's not constant, if it depends on n, your sequence is not geometric. Sorry about my writing.